Okay, so let's see how we can now take the 4x4 kernel and change it into an 8x4 kernel. So we start by saving this as gem 8x4 kernel.c. And now what we notice is that in order to store one column of matrix C, let's see, each column has 8 entries in it, we're going to need 2 vector registers. So each of these vector registers here needs to be duplicated. And what might we do there? Well, the second vector register that also stores parts of the first column is going to have the entries 40506070 in it. And the entries that need to be loaded into it start at the 40 entry of C. So we need to make those changes. And then we need to do that for the other vector registers as well. Let's see. Now I'm going to use a macro definition in Emacs to do my changes because that will be a lot faster. So this here changes it to 4567. Okay. And then I need to do the same thing here and the same thing here. And then I need to go over here and load this from 41, 42, and 43. So now what I've done is I've created vector registers and I've loaded those with the 8x4 submatrix micro-tile of C. Now then we go down here. I don't actually need a second vector register for B, but I do need a second vector register to store the pth column of A because it has 8 entries in it as well. So I do the same thing. I duplicate it, I change the name of it, and I load from entry 4P. And then what we need to do is we need to update 2 of the vector registers of C, the 2 that correspond to the first column, and that we do like that. And then you need to do that elsewhere. So you may want to take a break and fix your code now, or you can just follow along. So let's change this. Let's change this. And let's change this. And then finally we need to store the results back to where they belong. And again, we need to do that for the entire columns. 2 vector registers per column, and I changed the names of it. Let's see, did I do that right? Oops, one more. There we go. And then I need to make sure I store into the correct position. So I need to make this into a 4, this into a 4, this into a 4, and this into a 4. And in principle, we now have a correct implementation of the 8x4 kernel. So let's see how well that executes. So we go over here, and all we now do is say make ji 8x4 kernel, and the make file takes care of everything. This is going to compile and then execute, and this may take a little while. I'm going to fast forward. So I'm going to fast forward to where the result comes out. All right. Okay, so then we check whether we actually got the right answer, and it looks like we did, and then we transfer that file over so we can visualize the performance graphs. So let's have a look at that. Here's the graph where we have already plotted the results from the 4x4 kernel. What we now need to do is go up here, change the 0 to a 1. I always like to watch the graph as it changes, so if we now hit run, we wait for a little bit, and there is the new plot. And all of a sudden you notice that for small matrix sizes we're starting to do quite well.